Welcome to this overview and demonstration of Kemp's Zero Trust Access Gateway, or ZTAG. As many organizations are adopting object storage solutions and the ever-growing increase in threats, the need to secure these environments using zero trust principles has never been more vital. The Kemp Zero Trust Access Gateway is a security solution that's built on a customer's existing load balancer or application delivery controllers. Using the Kemp API, ZTAG is delivered via a policy builder script that ingests configuration files or policies that will permit or restrict granular access to published workloads. There are many supported use cases for ZTAG, but these will be dependent on the workload or workloads being published. But any users, devices, or applications attempting to access backend systems must meet the security policies enforced on the load balancer before they're given access. These policies will determine who a client is, have that be a user or an application attempting access, what that entity is attempting to do, are they requesting to read content, write content, or delete content, or where within the published workload is the request being sent. Here's an object storage use case where a customer has their modern applications running within different security zones. Security Zone 1 runs in a 10.10.10 subnet and contains applications that don't have many security requirements. These systems require access to the internet, which could pose a possible risk. Security Zone 3 runs in a 192.168.10 network and contains applications that require complete isolation due to security compliance. And Security Zone 2, although having to be more secure than Zone 1, it doesn't have the same level of requirements as Zone 3. Now, there's different approaches on how to apply a zero trust model to an object storage solution. In some cases, customers can leverage the object user account used to authenticate to the storage and apply policies based on that. But in this example, the same object user is being used across all three security zones, and they all require access to the shared storage solution. Furthermore, some applications require access to the same bucket, and under no circumstances should an application in the least secure zone have the ability to write objects to shared buckets that applications in the Security Zone 3 have access to. This is of course due to the lack of security enforced in those less secure zones and the possibility they could write malicious content which could compromise other secure applications. As we can see in the small example of the access policy, how the who, what, and where is defined. Security Zone 1 on 10.10.10.6 can only read from bucket 1, whereas Security Zone 2 can read and delete, and Security Zone 3 on 192.168.10.52 can read, delete, and write. So let's see the policy builder in action. Here we have an existing ECS connection manager in front of a 4-node Dell EMC ECS deployment. A virtual service has already been configured for S3 using TLS offloading, and our 4 nodes have been added. At this point, there's no rules set up, and therefore no zero trust configuration has been applied. With this simple configuration, I can connect to the storage from 2 different Linux machines running the S3 curl utility. This system with the black background simulates an application running in the least secure zone with a 10.10.10.86 address. The red background is an application in the most secure zone with an IP address of 192.168.10.86. From both of these systems, I have no trouble doing both reads, gets, and writes, puts, since no zero trust policies have been applied. Reviewing the policy file, which will outline the security that will be enforced in this environment, it's broken up into a few sections. The first section provides the connection information to the load balancer, ECS connection manager in this example. The next section is the virtual service configuration settings that will be applied to the virtual service. Here we have the real server configuration settings, such as the health check parameters and the real server ports traffic should be sent back to. Scrolling down, we have our real servers defined. In this example, the 4 ECS nodes. Now we start getting into the security sections. The first defines the networks or security zones that are within this environment. This section includes networks which are defined using regular expression or regex. The next section defines a security policy which will be enforced on the load balancer. Now there are a few buckets defined in this example, but for the demo we'll focus just on bucket 1. Here we see the 10.10.10 network has access to bucket 1, but only permission to read. The 172.16.10 network does not have any access to bucket 1. And lastly, the 192.168.10 network can read, delete, and write to bucket 1. Finally, the last two sections allowed for backup and logging options for each run of the policy builder. With the policy defined, I could just copy the path to the XML file, open up the policy builder in PowerShell ISE, and run the script. I'll click OK on the welcome message, paste the path for the policy XML file, provide the username and password to the load balancer. The first question we're presented with is whether we want to create a new virtual service or update an existing. Since we already have that TLS offloaded virtual service, we can update that to provide the necessary security for our object storage solution. A list of TLS certificates are provided since we choose to use SSL acceleration. The option to back up, so I'll go ahead and have a backup before any changes are made. Finally, what virtual service we want to update. A list of all virtual services will be provided, but since we only had one, I know this is the right one here. Now the policy builder will run through the configuration, creating new rules, reconfiguration of the virtual service, and apply all the new security rules to the configuration. Now that it's complete, if we look back at the ECS Connection Manager, we see the virtual service looks much different. Right, we have these security zones defined and the real servers listed beneath each. Also, if we look at the rules, we see that these have all been created and are applied throughout. Now jumping back to our Linux systems, if you recall, the 10.10.10.0 network only had the ability to read from bucket 1. So as you can see, I'm still able to do that, but if I try to write or do a put to bucket 1, I'm denied access at the load balancer. Yet at the 192.168.10 system, right, I can still read, and yet I can still write since the policy we applied allowed this access. Hopefully this demonstration highlights the capabilities provided and simplicity to enable a Zero Trust model to your object storage or other workloads using the Kemp Zero Trust Access Gateway. For more information or to download the Zero Trust Policy Builder, visit us at kemp.ax. Thanks for watching.